Hi there, this is Renee Rubocava and welcome to AutoNet. So today I want to talk a little bit about the worker framework that's actually shipped with the ArcGIS API for JavaScript version 4. A question came up on GeoNet not too long ago asking about how to use the API with web workers. And so the discussion came up about how to use this underlying worker framework that is inside the JavaScript API. And through this discussion, we realized that even though the worker framework itself is documented in the API documentation, there's not really too many samples of it, and that's only because trying to determine what kind of use cases a user might use for the worker and whatnot, it's kind of up in the air at the moment, just in terms of what can you as a developer use a web worker for. The user on here, Robert Hewlett, had a pretty good use case for what he was doing here, and he actually ended up showing a couple of YouTube videos showing what he was doing with the workers in here. This Huff example was a pretty good one to be able to run the analysis in the worker and then push the results back into the browser. That was pretty cool. So definitely recommend checking out his videos. I'll link them in the description of this video below. First off, let's look at the documentation for the workers. So we do document the workers in here. It's a very small utility framework in the API to simplify the use of web workers when you're using the JavaScript API. And it's just a very thin layer over what you can already do with workers and passing messages and everything. And it has a pretty good little diagram here showing you the different steps you would use to initialize the workers and get them going. Some documentation here, a couple little samples down here, this calculator sample and whatnot. So I thought I would try to do something a little bit more intensive. In this case here, this big old blob you see here, these are actually concentric buffer rings. So let's say, for example, you want to do this analysis and you want to create these concentric buffer rings. You could actually do that inside the worker. Right, and let's refresh that again, and as it's working, I can interact with the map. It doesn't slow anything down on the main thread because all the work for this is being done on the worker side. So it looks like a big blob right now because I think I created a few hundred or so of these circles here, but the idea is pretty much the same thing, right? You create your buffer, and I need to do it so many times around a certain point right here. And then I need to display that on my map. So this is pretty popular to do for a buffer analysis and stuff. You're probably not going to do this many concentric buffer rings, but you'd probably do maybe up to 10 or so, depending on the area that you're doing something with. And then maybe you want to run some analysis with those buffer rings as well. I would probably send them off to a server to do some analysis to figure out demographics or something like that within those buffer rings. So, okay, basically the idea here being is that you're going to load in the worker. All right, so we've bringing in Esri core workers, and then what you're going to do with those workers is you're going to have a URL to your actual worker file, your JavaScript file that you want to use. And you can just use this method here to get the local URL, because it has to be on your machine. Load it up, and you do workers open, right? Now, the first object you pass here can be pretty much anything. You can pass this if you're going to have some global methods that maybe you want the worker to be able to access. In this case, I'm just passing an object that has a method called progress. And this method should return a promise, because you may want to, when you call this method from the worker, you may want to pass something back to the worker, let it know, hey, I've got your results here. Maybe it's some authentication. So the worker needs authentication, goes back to the main thread, and you're going to send your credentials back, and you can use those credentials in the worker. All right, so that's the kind of thing you would do. In this case here, I'm just going to log out a progress message for what's happening in my worker. And I'm passing the worker URL here as a second argument when I open it. So first argument is going to be an object with a method that the worker can access, and a second object is going to be the URL to the worker file itself. Now this is going to return a promise, and in that promise you're going to get this connection. This is your connection to the worker, right? So instead of passing a message, you're going to invoke a method, and I have a method called magic, and I'm going to pass in that method extent. So essentially when I do the invoke here, I'm calling a method on my worker called magic, and it's going to expect to get an object with a property called extent. The results are going to be all of the geometries for these buffers. All right, I'm just going to go ahead and map over the results, turn them into polygon geometries, and I'm going to turn those into graphics here, small graphics array. You can see here they're not actually new graphics. I'm just turning them to graphic objects because view.graphics is a collection of graphics, and it knows to autocast something that looks like a graphic into a graphic there. The only thing that needs to be specified is an actual geometry, which is why I'm doing the polygon from JSON method here. It cannot autocast the geometries. Can't get that specific, but we know it's a graphic, so we're going to pass it in as a graphic. Now I'm just going to push in my marker. So that's the little blue dot here. So I'm pushing in my marker in there, and I'm just taking the centroid, the center of my extent that was originally used to do this buffer in here. All right, so then what I'm going to do is I'm going to go ahead and add all those graphics to my view.graphics, and I'm going to go ahead and zoom to the geometries that we returned. All right, so just zoom to all of those geometries. Okay, so let's get into the worker part. So in this case here, so what I'm doing is I just need to create a JavaScript class. Now you can create a class the ES6 way using the class keyword, or you can just do function class creation and using prototype to create your methods on a class. So in my case, I have a class with a method called magic. It expects a first property called extent, and then in this method you're going to get a second argument. This second argument is going to have a property called proxy. This is how you can call back to the main thread. On that proxy you're going to have a connection. Just like in the main thread we have a connection that we can invoke methods, we have this proxy connection that lets us invoke methods back to the main thread. So all I'm doing here is I'm sending a message to the progress method. Remember, if I come over here, I had my first argument with an object called progress. I'm going to invoke that method over there and just say starting. That's all. Just let the main thread, the web browser, the app know that I am starting whatever it is I'm trying to do. And then I'm going to go ahead and get the extent from my JSON here. And remember, you can only pass things like JSON objects, blobs back and forth within the worker. You can't try and send like a class. I couldn't send a graphics between the main thread and the web client itself. You can't do stuff like that. It needs to just be plain old objects. Right, so then what I can do is once I've got my area, I just let the main thread know that this polygon's been created. Now I'm getting the centroid from my polygon. I've got my little array of buffers which I'm going to save stuff in, and then I just send another message and let it know that I'm going to start my buffer creation. And what I do here is I have just a little for loop where I start with a buffer of 100, and I'm going to go up to 50,000 in increments of 100 feet. So that's all I do here is I create a point buffer, use Geometry Engine to create a geodesic buffer at the increment that I've got specified. So 100, 200, 300, 400, blah, 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 all the way up to 50,000 feet. Then I'm going to convert that to JSON and then push that JSON to my little buffers array that I've got sitting here. Then I'm just going to let the main thread know, hey, my buffers are ready to go. I'm done. I'm sending something back to you. And I just return a promise here with and this is the key part. When you return data from these invoked methods, so like this magic is being invoked from the main thread, you need to send back an object that has a data property. Whatever's in this data property is what's going to get returned as the result of the invoker method, whatever it was before. So if I come back over here, right, my promise that gets returned from invoking this method is going to have these results, and these are going to be my buffers. It's not going to have an object with a data property It's just whatever's in the data property, that's going to be my results here, and I can start working with it. So you can see it's pretty easy to do. I mean, maybe the most difficult thing for someone to think about is this invoke method, where you're passing a string of the method name that you want to access either in the worker or the main thread. But I mean, that's probably the most cognitively tricky thing someone has to wrap their head around at first, but it's really not that difficult. Once you've got that part, really just think of it as I have a object somewhere on the main thread of the worker, and I want to invoke a method by a certain name and pass the arguments to that method as the second property here. That's just, you think about it that way, and it gets pretty straightforward after that. So that's it. I mean, you can do an awful lot with these. If I come back here, refresh the app again, you'll see my console logs happen, let me know that I've started, that I'm done, and that I've got my results here. So that's how you can use the worker framework to do some stuff. I'm sure if people get familiar with it and start doing quite a bit more with it, you'll come up with some pretty creative ways to use this workers with the JavaScript API. There's still some modules that won't work inside of a worker. So you can see here, I'm able to bring in like the promise utils, geometry engine, extent, polygon, but you couldn't do like a query task in the worker. There's still some bits of the query task, I believe, that try to access window and a couple other things that you can't access inside of a worker. Same goes for things like, you couldn't try and initialize a map view in here because there's no document. You can't access document properties inside of a worker, and so on. So there's limitations to what you can do inside of a worker, but anything that is not DOM related could be done in the worker. So that's why things like doing geometry engine work is pretty powerful in a worker. And don't forget, there's a geometry engine async that you could use in your regular application anyway, and that offloads work to workers when it does what it needs to do for geometry engine stuff. But I just want to demonstrate here that I'm going to be creating these concentric circles, and it's kind of this might actually be a better way to do it inside of a worker here by doing the concentric buffers all together in the worker instead of having geometry engine async do multiple buffers and return all those different promises with different results back to do it. I think this is a little bit cleaner to do. So there you go. Play around with the workers, see what you come up with, have some fun with it. Thank you.